And you also, like I said, 9.7 deals with applications of growth and decay. So growth is when something gets larger and larger. Decay is when it's going to get smaller and smaller, okay? Um, and we're going to be looking at exponential growth. So remember your exponential graphs when we looked at those, your exponential graphs were the ones that sort of started out sort of mellow and then they started increasing really fast, okay? Now, we won't be graphing anything. I just wanted y'all to remember what exponential growth sort of looked like, okay? So I've got formulas we're going to be using. So y'all, the first formula will be for growth. And this will be exponential growth, okay? So P of T. Now, in these formulas, they use P a lot because P stands for populations. And population is an example of exponential growth, okay? Because the population can double after so many years and then double and double and keep on doubling, okay? So that's why they got a P in this formula. That stands for population. All right. So P of T is going to equal P original. So that's all one term. That stands for P original times E to the K times T. All right, so P of T. Now, if I'm using it for investments or population, this stands for the population or amount at any time T. So if I want to look at how many years, that's what the T stands for, time. Okay. So P of O, like I said, is the initial population or amount. So if I was doing an investment and I wanted to invest 5,000, that would be like my starting amount. Now, I would use this formula in my investments if I had continuous compounding. Now remember, if I had, say, semi-annual, quarterly, and stuff like that, that would be those formulas we used in 9.3, okay? All right, y'all, E is Euler's number still. That's on our calculator. K here. The K is the growth rate or interest rate. Okay. And then T is still going to be our time. And time we'll look at in years. Okay. So this would be for exponential growth. Now, if I was looking at exponential decay, it's the same formula, except the growth rate has a negative in front of it. So for decay, we will use the formula P of T equals P original E to the negative K times T. Okay. So there's a negative in the formula when it is a decay or a decreasing. Okay. Everything else stands for the same. Population at any time T, original population. K is still the growth rate. T will be the time. Now, what I've done on these formulas, sometimes they'll give us stuff and want us to find what K is. So if we want to find K, I've solved the formula so that we can find K using the following formula. It'll be K equals ln of parentheses or P of T divided by our P original and all that divided by our time. So if we're looking for the growth rate, we'll use this formula. And then if we want to use the formula to find time, we would use the next formula. Whoops, that should be semicolons. So to find time, our formula is T equals, and it's going to be the same formula, except we're dividing by K instead of dividing by the T. So it's going to be ln of P of T divided by our P original, all divided by K. So to find K, it's the ln of P T divided by PO, all divided by T. To find the time, it'll be the ln of the PT divided by PO, all divided by K. All right, y'all, now I got one more formula to give us, and then we will start playing with these examples. And this formula is what we call double time. So double time will be the amount of time it takes for your population to double or for your investment to double. So I would use this formula if I invested, say, $10,000, and I wanted to know how long it took me to double that 10,000 into 20. This would be the formula we use. Now it uses a capital T equals the ln of 2 divided by K, where T is now double time. K is still going to be the growth rate, okay? All right, y'all, so these are the formulas we're going to be playing with today. All right, y'all, so I'm going to start with number 1. All right, so for my number 1, it says in the year 2012, the population of a city was 5.31 million. So it looks like in this example, they're going to refer to our formula, and P will stand for population, actually, okay? Now, the exponential growth rate was 2.49% per year. Okay, so this is the information they're giving me. In the year 2012, the population of a city was 5.31 million. They're giving me the exponential growth rate. So for part A on this, part A wants me to find the exponential growth function. So they want me to find the formula that I would use for this problem to find the population at any time t, okay? Now, MATLAB will already have the P of t there. What we got to do is put in our formula. All right, so remember, P of t equaled P original. Well, the original would be 5.31 million So we're going to bring down our 5.31. Now, I'm not going to write million in here because it's understood whatever answer we get will be in the millions, okay? All right, so there's our P of O, and then we got our E. Now we need the exponent, which was K times T. So K is 2.49%. But y'all remember, we got to convert out a percent into a decimal to put it into our formula. So y'all, let me bring up my chat. So I want to know this for this question. What K would I put into my formula here? If this right here is my percent form, what would y'all turn the 2.49% into? 0.0249, good job. Remember, we're moving that decimal left twice, which means I have to add a zero. Good job. 0.0249. So that's going to go up here for K, 0.0249, and then that's going to be multiplied by T. So if I know how many years they're looking at, I can plug in for that T and plug into my formula and get the population that we would predict for those amount of years, okay? So y'all right here is what Math Lab is going to want. That right side of my formula. All right, y'all, so then they got a part B here. So check this out. For part B, they want to estimate the population in the year 2018. Well, y'all, we got the formula here, but what we need to find out is our T, the time. How much time passed between 2016 and 2018? Charles, what you got? 6. Perfect. Because my T is going to equal the 2018 minus the 2012, which will give us 6 years. So, y'all, that means we're finding P of 6. So that's going to equal 5.31 times E to the 0.0249 times 6. Now, y'all, on this one, it looks like they want me to round this to 1 decimal place. So, y'all, let's go to our calculator and punch this on. All right, so I had 5.31. Now, for these problems, I always use the second LN button because that'll give you the E with the exponent. And then I can put in my 0.0249 times my T, which was 6 years. All right, y'all, so let's hit enter, and we're rounding it 1 decimal place. So I got a 6.1, but the 1 has a 6 after it, so I'm going to make that a 6.2. All right, y'all, so 6.2 on that one. Now, MATLAB will have the million here. All we got to do is put in the 6.2. All right, y'all, so let's look at this one. So this one's a little bit trickier, but it says the population will be 9 million in about blank years after 2012. So 9 million would be my ending amount, my P amount. What I'm looking for is the years. So y'all, this formula, I'm going to use the one that's solved for time up here. Because this one's already solved for time, and that's what we're looking for on this one. So we're going to take our T is going to equal the LN. Our P of T is our ending amount, which was going to be 9 million. We divide that by our beginning amount, which is the 5.31. And then, y'all, that whole thing gets divided by K, which was 0.0249. All right, y'all, let's see. On this one, looks like they want me to round it 1 decimal place again, okay? So y'all look at this one. I'm going to do mine on my calculator here. So let me clear this off. First of all, I'm going to hit alpha y equals to get my fraction bars. And watch this. I'm going to hit LN. I'm going to hit alpha y equals again and enter and get the fraction bar again because the LN is of the fraction, which was the 9 on top, divided by the 5.31. I'm going to arrow out of that and close those parentheses. Then I'm going to the bottom and I'm going to put in a 0.0249. All right, y'all, so that now looks like exactly what we had written down. Now, think about this. The population was only 6.2 million after that 6 years. Well, they're looking at when it'll be 9 million. So it's got to be way more than 6 years, okay? So y'all, let's hit enter and see what we get. Remember, I'm rounding this 1 decimal place. So that looks like that's going to be 21 point. Well, y'all, that 1 has a 9 after it. So that means I'm going to round that 1 up into a 2. So that'll be 21.2 years. Now on that one, Math Lab will have the years here, and all you got to do is put in the 21.2. All right, and then finally, part D. It wants the doubling time. And I had a formula right here. Double time equals ln of 2 divided by k. This will tell me how long it'll take for the 5.31 to double into 10 million point 62, okay? So that'll be capital T equals the ln of 2 divided by my k, which is 0.0249. Hey, do you I want to see if y'all getting this one. So y'all punch this in on y'all's calculator and round me 1 decimal place. Just remember when you put that LN a 2 in it, close the parentheses and then do your dividing by and then put in your bottom. What you got? Ella, y'all got 27.8. Perfect. That's going to be 27.8. And then that's what you're putting in the math lab, and then they'll have the years out to the side for you, okay? All right, also, that's a trick on number 1. All of our formulas here, I would keep a good Keep these in a place that's easily accessible. Because if you got all these formulas, these problems are not bad, okay? You just got to figure out what am I looking for, so which formula would I use, okay? All right, y'all, so let y'all catch up on that. And on number two, they're going to have a table they want me to fill out. All right, y'all, so let's knock out this number two. So, y'all, my number two says complete the table. Now, my table, the first column is population. Under population, they got country A and country B. All right, the next column, they got the growth rate, which is our K. Now, for country A, they're giving me the growth rate of 1.9% per year. Now, country B, they're not giving me the growth rate. But when I find it, we're going to convert it to percent because that's what they got sitting by that box, okay? Now, over here in the last column is the double time, which is our capital T. Now, they're not giving me country A's double time, and that's going to be in years when we find it. But they are giving me country B's double time of 43 years. Now, the double time formula I can use to find the double time for country A. And then when we find our K, you'll see that the formula for K, when you got double time, is just swap the T and the K and solve it for the K, okay? So let's find the double time of country A. So that's going to be T of A. That's going to equal ln of 2 over the K for A. But y'all, I will not use 1.9% in the formula. What are y'all going to convert 1.9% into for my formula? We are putting up there, Carlitha, you and Ella, what's that? 0.019, good job. Remember, you got to move that decimal left twice and add me a zero there. All right, y'all, looks like on this one, we're going to round it one decimal place like they got. So when you punch this in the calculator, you're going to get a 0.01612. But y'all, this is not in percent form. This is decimal form. But we got to write the answer in percent. So since they want the answer in percent, you got to move the decimal back 2 spots. So here's the question. Are y'all going to keep this a 1.6?
Can you show me that on your calculator? Because I didn't get that.
Oh, did you not? Okay, so let me go to my calculator. All right, so I'm going to do the ln of, now if you want it, let me start over. I'll make it look like a fraction on that. So I'm going to go to alpha y equals and hit enter. So on top I had an ln of 2. So ln, put in your 2, close your parentheses. And then on the bottom we had 0.019. All right, so let me hit enter and see what I get. Oh, my bad, y'all, my bad, my bad. Hey, I see what I was doing. I was looking at the other formula for when I find the percent here. So my bad on that. Okay. So you get 36.48, round that one decimal place. That's going to be 36.5. All right, so that was my bad. So that was what, 36.48. And I'm gonna make that a 36.5. Well, I'm glad you caught that because I got both these written down and I was looking for the K part where I did the K instead of the time on it. So the double time, now look here. Oh, I went too far on that. I didn't even have to round that one decimal place. They just wanted this rounded off to the nearest year. So since that's 36.4, the 4 is less than 5, we'll keep that at 36. All righty, so thanks for catching that for me, okay? Now, the second one we got to find is the K for country B. So you ought to find K when you got the double time. It's going to be the ln of 2 divided by that double time, okay? So let's see what we get here. ln of 2 divided by the t they gave me at 43 years. So hey, punch that one in and tell me now, are you getting the 0.01612? Yep. Okay. So 0.01612. And remember, they wanted it rounded one decimal place. So you got to move the decimal back right to do your percent. So it's going to be 1.6, and I'll keep that a 6 since it's got a 1 after it. So that'll be 1.6. Okay. So to use the growth rate in the formula, you got to turn it into percent decimal form. In the answers, they want them in percent form, okay? All right, also that's number 2. You just had to complete the table and find those two amounts. So let's see what number 3 has in store. All right, so my number 3 is one of those interest type problems on investments, okay? So the problem I got for number 3, they're telling me that $10,346 is invested at 5.1% per year, compounded continuously. So this is why I can't use the formulas I taught y'all in 9.3, because those were being compounded monthly, semi-annually, quarterly, and all that stuff. This is compounded continuously. So for part A, just like on the first question, they want us to find the exponential growth function. All right, so that's going to be our P of T. Now remember, MathLab's giving you the P of T. What we got to do is fill out everything in our formula. So we need our P original. Our original investment. Well, that's the 10,346. Then we got E. All right, y'all, what am I putting in for my interest rate or growth rate, what you call it, okay? 0.051, good job. 0.051. So she just moved that decimal left twice. And then we have our T. So this will be the formula we're going to use for part B of this problem. So look at part B wants. Part B wants to know what is the balance after T equals 1, 2, 5, and 10 years. On this one, they want me to round to the nearest cent. So when they say round to the nearest cent, they want 2 decimal places. Now, I'm going to show y'all how I use the calculator to do this one. Well, I would use the calculator no matter which way I do it. But one way is to punch this in and put in a 1 for T and get that amount. And then punch all this in again, put in a 2 for the T, get that amount. Punch it all in again, put a 5 in for the T, and then with a T, 10 in for the T. But y'all, graphing calculators are nice because we can do all this by just punching this in one time. Okay? So what I'm going to do is I'm going to put my equation into y1. Now, the thing you got to remember when you use y1, instead of a t here, I'm going to put an x, okay? Because on the calculator, when you go to y1, those are in terms of x's instead of t. So y'all, let me see here. Let me clear everything off. I'm going to go to y equals. I'm going to put in my equation, which is 10,346. I'm going to hit second ln for my e with the exponent. And then that is 0.051 times x. Remember, on the graphing calculator, you got to use the x, okay? All right. Now, all my values that I'm looking for are going to be in the table. So to get to the table, you hit second graph. All right, so my first t or x is 1. Now, y'all look at this. When I highlight the 1, the y value is 10,887. But that's not in decimal form. And it's not rounded. So what I need to do, watch this. If you will highlight the y value and look down here in this bar where it says y1 equals 10,887 point, and it's got my decimals, I can now round it off 2 decimal places, and that'd be a 0.33 for that one. So when t equals 1, I had $10,887.33. Then it was for t equals 2. For t equals 2, I'm going to go down 1 in my y values. And see that 11,457 is rounding it to the nearest dollar. But when you look down here in the bar, y1 equals $11,456. Rounding that one 2 decimal places, that's going to be a 0.99. All right, what was next? T equals 5. So for t equals 5, I need to go down. There's 3, there's 4, and there's 5. So we're all rounding this one off. I got $13,351.12. So my second one had a 5 after it, so that's going to become a 0.12. And then y'all had for t equals 10 years. So go down 5 more to get to 10. So there's 10. And at 10, I get $17,229. And what's that? 10. Yeah, that'll stay 10 since it's got a 2 after it. So, y'all, that's a trick on those, okay? Otherwise, you would have to punch those in individually, okay? But, y'all, they're not bad individually. Let me do it for the t equals 1. 10,346. Second ln for my e. And then that'd be 0.051 for 1 year. It'll give me all my decimals. And y'all, that's the one I had 10,887 and I rounded it off to 0.33. So you can do them individually, or like I said, use the graphing, okay? Hey, also, that's the first three on this. They're not too bad. You just got to play with them formulas and see what are you really looking for, okay? All right, y'all, so let's move on to number 4. Now, I will say this. Number 4, they're going to give you a table. So for number 4, they're giving me a table. And on my table, they have a year and then the percent of married adults. So this was out of a certain country. Um, so the first year was 1960, and then it goes to 1980, 2000, 2010, and then finally 2012. Okay, the percent of married adults was 68.6 in 60, 56.4 in 80, 51.4 in 2000, 47.6 in 2010, and then 40.6 in 2012. So look here. The percent of married adults is decreasing over time. Okay? All righty, y'all. So for number 1 here, well, for question A, I mean, for A, they want me to use the table for 1960 and 2012 to find the value of K. Now, I gave you a formula a while ago to find K. And that formula was K equals the ln of your P of T over your P original, all divided by your T for time. All right, so for this formula, since we're using 60 and 12, 2012 is going to be our P of T, because that's the ending amount. And 1960 up here is going to be our P original. Okay? And then we'll figure out how many years are in between 1960 and 2012. So y'all, here we go. ln of P of t was 40.6 over P original 68.6. All of that's divided by, well, y'all, how many years is in between 1960 and 2012? What would y'all put down here for my time on that? All right, Carlith, what y'all getting? 52 sounds good. If you do 2012 minus 1960, you'll get 52 years. All right, y'all, this one they want me to round 4 decimal places. Okay, so I'm going to go to my calculator and let's punch this in. All right, I'm going to make it look like a fraction. Alpha y equals enter. I'm going to do my ln, and then I'm going to do alpha y equals again for another fraction bar. So on that one, on top, we had 40.6. On bottom, 68.6. All right, I want to arrow out of that, close those parentheses. And then on bottom, Carlitha, let me know. Okay, that was 52. All right, y'all, we're rounding this 4 decimal places. So K will be a negative 0.010. All right, y'all, I'm looking at that next zero for my fourth spot, but I got a 1 after, I mean, a 8 after it. So since that zero has an 8 after it, I'm going to round that second zero into a 1. So then I get a 0.0101. All right, y'all. So let's go back now.
I have a question.
I hear you.
So why didn't we um fix the decimals on the percentage that of adults who are married? Like
You
why
what
didn't
now?
we round it backwards? So for all of the percentages we've been rounding, like we've been moving the decimal spot, why didn't we do that for the
Oh, because, yeah, they're understanding. Yeah, it's not like your interest rate or growth rate, though. So I see what you're saying. But on this one, we're just looking at the amounts versus the, yeah,
so you only have to do that on like the interest rate or like you only have to do that on the K?
on the K only.
Okay.
Yeah. Yeah, because any answer I get on this when I use the actual formula is going to be understood to be in percents, okay? All righty. So then that one wants you to. Now listen, here's the thing on this one. When you put this A into MATLAB, you don't want to put the negative. Although that's negative in MATLAB, you're just putting in the K value, not the sign, okay? Now, that's one thing I didn't like about MATLAB on this question, but the K will be in the formula as negative, but they just want the 0.0101 put in as a positive number. Now, part B on that had m of t equals. When you put in the formula, though, you got to use the negative. So it'll be the 68.6, which was my P original, times E to the negative 0.0101 T. So in formula, the negative is there, okay? But when you put K in for this first answer, do not put the negative. I don't know why math lab's picky like that, but they are. So on that part, I'm putting in this right here. All right, y'all, then B says, using this formula right here, we're going to estimate the married adults in 2015 and 2018. Okay, so 2 different years we're going to estimate the married adults. Now, 2015 and 2018 are higher in years than this one. So those percents better be less than 40.6 because this stuff is declining as we go, okay? So let's use this formula first and let's play with 2015. So we're going to find M. So y'all, that's T going to be. So for 2012, T was 52 years. You're 3 years further. So add 3 more years to that, and that 52 will become a 55. So we're looking at 55 years for T. So here's our formula, 68.6 E to the negative 0.0101 times 55. Now, y'all, when you do this one, we're rounding it 1 decimal place. So do one of y'all want to punch that in and see how many married adults we'll have in 2015? And then we'll do it for 2018. And y'all remember to round this thing off 1 decimal point. All right, so what do we got? 68.6. Second LN to get my E with my exponent. And then I had a negative 0.0101 times 55 years. Oh, you're a perfect Carnethia, but 1 decimal point. So turn that 36 into a 0.4 and you'll be perfect. So good job. Those are sort of tricky to put in, but once you get the hang of them, they're not bad. So that one, Carnethia, I'm going to go with 39.4. And then MathLab will have that sort of percent sitting there for you. All right, so 2018, what is that? So that was 2015 was 55, so that's 3 more years. So this one will be finding M of 58. So that'll equal 68.6 times E to the negative 0.0101 times 58. All right, it better be even less than 39.4. So y'all punch that in and tell me what we get for our married percent in the year 2018. 38.2, perfect, y'all. 38.2. All righty, y'all. So that was using that formula to estimate 2015 and 2018. Now look at part C on this one. For part C, they want to know at this decay rate, in which year would a percent of married adults be 30%? So we're looking for the year. So what we got to do is use our formula for time and see how many years it's going to take to get down to 30%. Once I know how many years it's going to take, I will add that to the 1960 and get my final answer. Now I know this, at 2018, it was at 38.2%. So it's going to be a lot more than, what do we get here? 58 years to get to here. So it's definitely going to be more than 58 years on this, okay? So remember, for time, our formula was the ln of my P of T, which is going to be the 30%, because that's the ending amount, divided by my initial amount, which was 68.6. And then all that divided by my K, which was a negative 0.0101. All right, y'all. So let's go punch that in and see how many years after 1960. All right, so I'm going to do my fraction. Right on top, I have ln. I'm going to do another fraction for that. On top was 30. On bottom was my 68.6. I'm going to arrow out from that and close my parentheses. And then I'm going to the bottom and I'm going to put in my negative 0.0101. Now, you're going to round this off to the nearest year. Oh, Carnithia, you go now because I think you're pretty good on that. So when you're done this part, let's see. You should have got 82 years. Good job. So I'm going to round to 81 into 82 because I had an 8 after that decimal. Now, get me the year that'll be by adding 82 to the 1960. So we'll take our 1960, add the 82 to that. So Carl Ethan, knock that out, and what'd you get? 2042. Good job. So y'all, sometimes they'll say at this decay rate, the percent of married adults will be 30% blank years after 1960. But this one actually wanted the year here, so we had to add them back to the 1960 and get our years for it, okay? Oh, that'll be sort of like this number 6. So y'all, let y'all write that in real quick, and then we'll knock out our last problem. I mean, number 5. I will say this, y'all. This is if you're in, say, business classes or finances, you might use these formulas for interest and investments. If you're a biologist or into biology or something, you might use these formulas for like, oh, let's say you work for the Game and Fish Commission, you might use these formulas to estimate the population of deer and things like that. When they estimate there's a certain amount of deers in Arkansas and stuff, they're doing this kind of stuff, okay? All right, y'all, let's knock out this last one. The last new problem I'll do with y'all this year. All right, so let me see what that is. Okay, this is about cars. So there are 55 million cars in a country decreasing by 1.7% annually. They want to know how many years until the country has 30 million cars. So about half of them, right? 55 million. They want to know how long will it take before it has 30 million. So y'all, once again, I'm looking for T. Now this one ain't asking me for the year. It just wants to know how many years until it has 30 million cars. Okay, so they're not giving me a beginning year or an ending year. We're just going off of what they got here, okay? So we're going to use our formula for time. So for time, it equals the ln of P of t divided by our P original all over my K. That's going to be the ln. All right, so my ending amount was 30 million cars. My original amount was 55 million. Now, y'all, here's the 1.7%. Let's turn that into a decimal. So, L on this one, you actually got to turn this one into a decimal because it's going in for the K, okay? All right, so what's that going to give me? I'm going to go 2 left, and that's going to be a 0.017. Let me ask y'all this. When you put that 0.017 into the formula, are you going to make it positive or negative? Negative. Good job, because this stuff is decreasing. So that's going to be a negative 0.017. Okay. So K is negative since the cars are decreasing. Well, y'all, let's push that in and see what we get. All right, so I'm going to clear that out. And once again, I'm going to do the alpha y equals for my fraction. I'm going to hit ln. And then I'm going to do the alpha y equals and my fraction. All right, y'all, so it looks like top is 30. Let's see, Carly, what you got? 36 years? So we will round this one to the nearest year. So I think you're perfect there. So let me see. So 55, close my parentheses. And then on bottom was what, a negative 0.017. All right, I think you're perfect. So let me punch that in and see. So 35.6, they want to round it to the nearest year. So that's going to be a 36. All right, good job, y'all. All right, so y'all, that's what they want. And then so MathLab will say, oh, y'all on that one, guess what? MathLab had an A, B, C, D answer for that one. So you had to get it right on that one because that was one of their choices, A, B, C, or D, okay? All righty, y'all remember, Thursday of this week, I think Thursday's what, May the 1st? Let me look on my calendar. So Thursday, May the 1st, I'm going to review for test 4, okay? Monday, let me see, let's see, Thursday be the 1st, so second, third, fourth. So that'll be the 5th. Monday, May 5th, I'm going to do the final exam review. Okay. Wednesday, May 7th, Wednesday, May 7th, final exam opens. And this final exam is due by Sunday. Let's see, 7, 8, 9, 10. Is that the 11th? Sunday the 11th? Yeah. Sunday, May 11th, the final exam is due. All right, y'all. So that's my schedule coming up. Thursday, we're going to do final test 4. Oh, and I said Monday, not Monday, but this will be Tuesday, May 6th, right? All right, my bad, y'all. Tuesday, May 6th, we'll do the final exam review. And then the next day on Wednesday, it's going to open and be due by Sunday, May 11th, okay? All right, y'all, any questions on that? Hey, so Ella, were you following along on your work this time? Were your problems pretty similar to mine?
Yes.
Okay. That's what I want to make sure. Sometimes they'll change stuff up on me. So as long as y'all's is like mine, we're good to go. All righty, y'all. So I guess y'all survived college algebra, right? Y'all, any questions?